Let me next welcome to the stage from Los Angeles, Parthian Energy.
So my sister, she was supposed to come here, but she couldn't make it. So I'm presenting on behalf of Parthian. I'm Farshid Rumi. I'm the founder and CEO of Parthian. And so we are working on developing a new class of battery monitoring systems. So with our technology, I tell you how we can learn much more about the batteries that we have and we are using everywhere in our cell phones, in EVs, grid storage, or in space. And I tell you why it is important. And it all started when we were working on making high energy batteries. So the goal that we have is developing batteries with 500 watt-hour per kilogram. So for that, you need lithium metal and you need thick cathode. So we have been working on that for a long time, but then a major problem we had was that how can you prove that it works? Because in batteries, things are so slow because the measurements are so slow. It takes forever to test a real battery. And it was so frustrating that so we were working on lithium metal batteries, and we had to wait weeks to see that, oh, it's not working. And then we were working on thick cathode. Again, you have to work weeks to see it doesn't work. So then we developed a new technology so that we could speed up our own progress on testing our batteries. And just we know that now batteries are really hot, and then we realized that maybe we should commercialize this technology first before we move to our high energy battery. And we see a great opportunity here. The opportunity is that the battery measurement technology has not changed since the first battery was commercialized more than a century ago. So all you can learn about your batteries today, a cell phone or EV or anywhere, is the voltage. So if you have a battery, assume this is a battery, all you get is just one number for what's going on inside. It's a complicated system, but you only have one number. That's just the voltage. And we show you how you can get a lot more information, useful information from your battery. And this is a NASA event, and so we thought we should also mention that batteries are really important for NASA missions, especially because you have it in the proximity of humans. And also you need a lot of batteries for having electricity, not only for just the International Space Station, but also for commercialization of the space. If you want to have a hotel there, you definitely need a lot of batteries there, and the batteries will be huge. And you can think about what may go wrong if one of the batteries catches fire. And the batteries catch fire, although there's no oxygen there because they have oxygen in the cathode. They don't need oxygen from the air. And when the battery catches fire, it can be really bad. So on the left, there is a video. I don't show you the video, but there was a robot that was being tested by NASA, and the people working with that left it to go get lunch. They came back. They saw that the whole lab is on fire. And it took a real effort for the firefighters to put off the fire. So you can see that battery fires are not something that we can ignore. We should take them really seriously. And especially for a space, if you have a problem with the battery, you have these orbits that are really expensive to work in. So you don't want to pollute the orbit with having a battery explosion, having many parts of the satellites moving around. And one thing very important here is that so batteries, we may think that we know batteries, but batteries are somehow new. Still, they are new in terms of the technologies that we use. So satellite batteries are mostly maybe at most like 25 years old. So that's still really young. But once batteries age further, what will happen is that like the chance of batteries catching fire goes up significantly. And then we talk about commercialization of the space. So it's similar to what we are doing with other devices on this planet, that you need a lot more batteries. So for the space, you need many more batteries. So if you want to commercialize the space, you need 100 times more batteries. That means that statistically, the chance of having a fire incident is 100 times more. And that's exactly the lesson that the EV industry learned. So the problem there was that they thought batteries are safe. So when we started commercializing our technology in 2017, like we were approaching many battery makers and automakers, and they were all saying that we are safe, we haven't had any incident, or we have a really low chance of having an incident. So they were ignoring us. But then just in the past 1 year, we see that, like, because we have so many EVs now on the road, we see so many recalls and so many fire incidents. So just one recall like cost more than $2 billion for a battery manufacturer. And the reason is not that the technology that they have is bad. The reason is because, like, if you have more of one thing, then you have a higher probability of problems. And it's very important to make sure that these rare events don't happen, because these rare events, if they happen, they can kill an industry. And that's what happened with supersonic aviation. So a key reason that supersonic aviation died was because of one fire incident. So now we talk about why do we have these incidents now? So what's the problem now? And what is it that we are competing with? So right now during manufacturing, that is when the quality control is being done. And the quality control has a step called aging, that during aging, the batteries are being tested for several weeks. And this is a very expensive and really a slow process. So this adds $5 to $9 per kilowatt hour to the battery. So it's easily more than 5% of the cost of a battery cell. Cell is just one battery without any electronics. So this is really expensive, and what the industry has been doing with this was good before we have so many batteries. And the chance of having some problems there is 0.1 ppm. So during this process, they have the batteries just sitting for 2 weeks, and they just measure the one number, the open circuit voltage of the battery, to see if it drops or not. So this is something that could be done 2 centuries ago, and we are exactly doing the same thing today. But because the technology is so raw, then they throw away between 5 to 15% of the batteries. So not only it's expensive, but also there is a huge cost, because there are batteries that might be really good, just showing some problems, and they have to throw them away because they don't want to have fires in the field. So if you have a technology that can speed up this process while adding the precision and accuracy, the battery manufacturer can make a lot of money. So here I show you what people are doing now during manufacturing. So they have these trays that I mentioned, that then you have these single cells, you put them in the trays. So this is a huge part of a battery manufacturing. And as I mentioned, voltage monitoring, it takes forever to see a voltage drop. And then if you have temperature changes, then that affects the voltage, and it's really expensive and hard. So if you want to increase the ppm, if you want to increase the safety by lowering the probability of fire, then you need to test batteries for much longer, which is not possible. So you cannot test batteries for months. So the device that we have developed is the next generation of battery monitoring. So instead of just getting one number from your battery, the number being the voltage, we try to see what else we can get, because failure doesn't happen just at once normally. Normally you have something, we have some hot spots, some small variations inside the battery that are bad, and those are things that can grow and affect the battery later, causing a problem. So what we have is based on electromagnetic field monitoring. So you have an antenna. This is a very low-cost antenna, similar to the antennas we have in our cell phones for different reasons, or like Wi-Fi stuff. So with that antenna, we get the electromagnetic field of the battery, and then we have some machine learning program on top of that And based on that, we get not only the map of what's going on inside the battery, but also we can predict what will happen. So, and why is it important? Because if you do fast charging, what happens is that in your battery, like as you see in that map, so that map, you can think about it as the map of the resistance inside the battery. So if you see any abnormalities there, then you would know that that abnormality can later grow and affect the battery. So right now, people talk about fast charging. We want to charge our electric cars in 5 minutes, 10 minutes. We cannot do that because we don't know what's going on inside the battery. We just have one number. But if you can see what's going on inside, then you can see that hot spot being developed and then further growing. So you can predict that, yes, if you continue fast charging with this rate, then you will go and have a problem with your battery, the battery losing power, or even catching fire in the future. And in terms of the patents, so as I mentioned, we are also working on batteries in general, high energy batteries. That's like we are talking about the whole package of anode, cathode, and the monitoring. And we have 25 issued patents, or maybe more, and about same number of pending patents. And the patents are mostly filed by Caltech because that's where we started the work. But now all exclusively licensed to our company. And so there are many applications for this technology. Now that you can see a lot more, you can get a lot more information about your battery. There's so much you can do. So the first thing that we thought we could do was talking with automakers and helping them prevent battery fires. So you can think about like our device being just something very thin, and then I mentioned during manufacturing, but that time we realized that we cannot reach out to the manufacturing people, so we went to the OEMs making automakers. So this thing can be just near the batteries. It doesn't need to be connected at all physically because it's electromagnetism. And we wanted to tell them that we can detect these battery fires, that you may have heard that someone was driving an electric vehicle, and suddenly the car caught on fire for no reason. Or if it is parked in the parking and it catches fire. And then they learned that, oh, it was because 2 months ago they had a bumper-to-bumper accident, very minor, but even very minor that can cause problems inside the battery or outside of the battery. And that can develop. And voltage cannot see it. So here I show you an example. So here we designed an experiment. It was with Oak Ridge National Lab for a major automaker. So you have a fresh commercial cell. It is 500 milliamp hour, about this size. And then we generated an internal short inside it. And we made the short very gradual so that it can represent the way that these small internal shorts happen, like, as I mentioned, a car accident, a very minor one. Or it can be a manufacturing defect. And as you see, oops, sorry. So as soon as we create the internal short, electromagnetic field only cares about information. So if you have a short inside, there is information you are sending out to the space, and we were receiving that information. As you see, this pink here is our sensor. So it got the information that, hey, there is an internal short. But then the voltage didn't see anything, and the voltage here was being monitored by an oscilloscope. So we wanted to get the most accurate device we have to measure the voltage. So it doesn't detect it at all. And we were making the internal short so gradual that even with our eyes, we could see that the battery is damaged and the temperature was going up. But it was taking minutes. In this experiment, we designed it to do minutes. We could do it for much longer or shorter. Like, the voltage was not showing anything. And that is why, like, you have this fire incidence. So that's why, like, suddenly you have a battery fire, EV fire, out of blue, and you have no idea why. It was there, you couldn't see it. So because we can detect it before it changes the voltage, now you can take action. Taking action here is removing the internal short, so the battery would be safe, the device would work. But it can also be valuable for fast charging, as I mentioned, because during fast charging, we don't do fast charging because everyone in the industry knows that if you do fast charging, something similar to this may happen. Your battery might be damaged, you may not see it. So that's why the charging rate of the batteries for EVs or everything is limited. So with this technology, we can remove those limits to some points. And then we thought about, so who's going to pay for it? As I mentioned, we were working with an automaker, but then we realized that they don't want to pay because manufacturing should pay. So in the manufacturing, we can think about this part being the aging part, which is a really expensive part of a capital, so it is 20% of the capital, and it adds the 5%, as I mentioned, minimum to the battery cost.
I'm sorry, that's time.